It is not permitted by the National Electrical Code to combine 120 volts and 277 volt circuits at a switch. National Electrical Code Section 384.30 states that circuits of different voltages, frequencies, or types of current shall not occupy the same equipment such as a switch or overcurrent device unless the equipment is approved for the purpose. Section 384.14 requires that switches have a voltage rating that is equal to or greater than the highest voltage applied to any of the terminals. Combining different voltages at the switch creates a potential safety hazard. If a fault occurs on the 277 volts lighting circuit, high voltage could potentially be present in the 120 volts exhaust fan circuit, posing a shock or fire risk. To comply with the code, the 120 volts exhaust fan and 277 volts lighting must be controlled by separate switches. The switches must be appropriately rated for the respective voltages. When dealing with electrical systems, understanding and adhering to the National Electrical Code is paramount for ensuring safety and preventing hazards. The code provides detailed guidelines and requirements for electrical installations, addressing various aspects such as wiring methods, overcurrent protection, granting, and equipment specifications. Firstly, consider the fundamental principle of separating circuits with different voltage levels. This principle is rooted in the need to minimize the risk of electrical shock and fire. When circuits of varying voltages, such as 120 volts and 277 volts, are combined within the same enclosure or device, the potential for a fault to propagate from one circuit to another increases significantly. A fault on the higher voltage circuit could introduce dangerous voltage levels onto the lower voltage circuit, potentially endangering personnel and equipment. Secondly, the National Electrical Code Section 384.30 explicitly prohibits the mixing of circuits with different characteristics within the same equipment unless that equipment is specifically approved for such use. This requirement ensures that devices like switches and overcurrent protection devices are not subjected to voltage levels or current types that they are not designed to handle. Using equipment beyond its rated capacity can lead to premature failure, overheating, and potentially hazardous conditions. The approval process for equipment intended to handle multiple voltage levels typically involves rigorous testing and certification to ensure that it can safely isolate and manage the different circuits. Thirdly, the National Electrical Code Section 384.14 further emphasizes the importance of selecting switches with appropriate voltage ratings. This section mandates that switches must have a voltage rating equal to or greater than the highest voltage applied to any of their terminals. This requirement ensures that the switch can safely interrupt the circuit under normal and fault conditions without experiencing dielectric breakdown or other failures. Using a switch with an inadequate voltage rating could result in arcing, insulation failure, and potentially a fire. Furthermore, consider the practical implications of combining 120 volts and 277 volt circuits at a switch in a restroom setting. In this scenario, the 120 volt circuit typically powers the exhaust fan, while the 277 volt circuit supplies power to the lighting fixtures. If these circuits were to be combined at a single switch, a fault on the 277 volts lighting circuit could potentially energize the 120 volts exhaust fan circuit with a much higher voltage than it is designed to handle. This could lead to insulation breakdown, equipment damage, and potentially an electrical shock hazard for anyone who comes into contact with the fan or its associated wiring. To avoid these risks and ensure compliance with the code, it is essential to maintain separation between the 120 volts and 277 volt circuits. This means using separate switches, each appropriately rated for the voltage of the circuit it controls. The 120 volts exhaust fan should be controlled by a switch rated for 120 volts, while the 277 volts lighting should be controlled by a separate switch rated for 277 volts. This separation provides a critical layer of protection against potential hazards and ensures the safety of the electrical system. When installing separate switches, it is also important to follow proper wiring practices and use appropriate wiring methods for each circuit. The conductors for the 120 volts and 277 volts circuits should be kept physically separated and clearly identified to prevent accidental contact or confusion. Additionally, the wiring should be installed in accordance with the National Electrical Code requirements for conductor sizing, overcurrent protection, and grounding. Overcurrent protection devices, such as circuit breakers or fuses, are essential for protecting electrical circuits from overloads and short circuits. These devices are designed to automatically interrupt the flow of current if it exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. The overcurrent protection devices for the 120 volts and 277 volts circuit should be sized appropriately based on the ampacity of the conductors and the requirements of the connected equipment. Grounding is another critical aspect of electrical safety. Grounding provides a lower impedance path for fault current to flow back to the source, allowing the overcurrent protection device to quickly trip and energize the circuit. This reduces the risk of electrical shock and helps to prevent equipment damage. The grounding system should be installed in accordance with the National Electrical Code requirements for grounding electrode systems, grounding conductors, and equipment grounding. In addition to following the specific requirements of the National Electrical Code, it is also important to consider general safety practices when working with electrical systems. Always de-energize circuits before working on them and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not qualified to perform electrical work, it is best to hire a licensed electrician to ensure that the work is done safely and correctly. Regularly inspect electrical systems for signs of damage or deterioration such as cracked insulation, loose connections, or corrosion. Address any issues promptly to prevent them from escalating into more serious problems. Furthermore, consider the broader context of electrical safety in commercial and industrial settings. These environments often have more complex electrical systems and higher voltage levels, which can increase the risk of electrical hazards. Implementing comprehensive safety programs, providing regular training to employees, and conducting thorough risk assessments can help to minimize the potential for electrical accidents. In addition to the technical aspects of electrical safety, it is also important to foster a culture of safety within the organization. This means promoting open communication, encouraging employees to report hazards, and recognizing and rewarding safe behavior. By creating a strong safety culture, organizations can help to prevent electrical accidents and create a safer working environment for everyone. Consider the implications of using a two-pole switch in this scenario. A two-pole switch is designed to simultaneously switch two separate circuits or conductors. While it might seem like a convenient way to control both the 120 volts exhaust fan and the 277 volts lighting with a single switch, it is not permitted by the code due to the voltage difference and the potential safety hazards. The use of a two-pole switch could inadvertently create a connection between the two circuits, leading to the risks described earlier. Therefore, it is crucial to avoid using a two-pole switch to combine circuits with different voltage levels. In summary, combining 120 volts and 277 volts circuits at the switch is a violation of the National Electrical Code and poses a significant safety hazard. To comply with the code and ensure the safety of the electrical system, it is essential to use separate switches, each appropriately rated for the voltage of the circuit it controls. Follow proper wiring practices, use appropriate overcurrent protection and grounding, and adhere to general safety guidelines when working with electrical systems. By taking these precautions, you can help to prevent electrical accidents and create a safer environment for everyone. When faced with situations involving different voltage levels, it is always best to consult with a qualified electrician or electrical engineer to ensure that the installation meets all applicable codes and standards. These professionals have the knowledge and experience to design and install electrical systems that are safe, reliable, and compliant with all relevant regulations. It can also provide guidance on selecting the appropriate equipment and wiring methods for specific applications. Staying informed about the latest updates and revisions to the National Electrical Code is also crucial for maintaining electrical safety. The code is updated regularly to reflect new technologies, best practices, and lessons learned from past incidents. By keeping up to date with these changes, you can ensure that your electrical systems are always in compliance with the latest safety standards. Furthermore, consider the importance of regular maintenance and testing of electrical systems. Over time, components can deteriorate, connections can loosen, and insulation can break down, increasing the risk of electrical hazards. Regularly inspecting and testing electrical systems can help to identify potential problems early on, allowing you to address them before they lead to more serious issues. Maintenance activity should include visual inspections, insulation resistance testing, ground impedance testing, and overcurrent protection device testing. Any issues identified during these tests should be promptly addressed by a qualified electrician. In addition to the specific requirements for combining different voltage levels at a switch, the National Electrical Code also addresses a wide range of other electrical safety topics. These topics include wiring methods, overcurrent protection, grounding, bonding, equipment installation, and special occupancies. Familiarizing yourself with these topics can help you to develop a comprehensive understanding of electrical safety and ensure that your electrical systems are installed and maintained in accordance with the code. The National Electrical Code is a complex and comprehensive document, and it can be challenging to navigate and interpret its requirements. However, understanding and adhering to the code is essential for ensuring electrical safety and preventing hazards. By taking the time to learn about the code and following its guidelines, you can help to create a safer environment for yourself, your family, and your community.